Okay, here's warm-up 12.4. So we've got bags of fruit on these first two problems, and we're going to find the probability of randomly selecting 3 apples in a row without replacement. So the key phrase here is without replacement. So yeah, we're looking for the probability pulling an apple, then an apple, then an apple. Okay. So we're going to be doing some multiplication here. So first we'll just find the probability of pulling the first apple out randomly. Okay. And then we're going to find the probability of pulling, well, let me start with that, just the apple. So there are 4 apples in the bag, and let's see, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of fruit. So 4 out of the 9 are apples. Okay. On my second draw, though, I got to assume that an apple has already been removed because I pulled an apple out of the bag and I didn't replace it. So that one's gone. It's not in the bag anymore. That means there's only 3 apples left, and there's only 8 total pieces of fruit. Okay, so this symbol means pulling an apple, assuming that an apple has already been removed. Okay, and then on the third draw, I'm going to find the probability of pulling an apple, assuming that 2 apples have already been drawn out. I kind of ran out of space there, but so now 2 apples have been removed. There's only 2 apples left in the bag, and there would only be 7 pieces of total fruit left. Okay, and then I multiply straight across. So on top I've got 12. Let's see, 9 times 8 times 7 is 504. Okay, and so I've got 12 over 504, and I want to reduce that as well. That's going to reduce, you can divide by 12, and it's going to reduce to 1 over 42. 12 goes into 12 and 504. Okay. Or you could do the percentage version of that. Okay, so now let's try it again. We're going to do the probability of pulling an apple first, and then an orange. And this, again, is without replacement. So we'll find the probability of pulling an apple, and then the probability of pulling an orange, assuming that an apple has already been removed. Okay, assuming the first event has already happened. So there's 4 out of the 9 pieces are apples to begin with, but then we're going to remove one of those apples. Now we've got, let's see, 1, 2, 3, 4, 5 oranges, and there's 8 total pieces of fruit left. So then I've got 20 over 72. Let's go ahead and reduce that. That's going to reduce to 5/18. You can divide the top and bottom by 4. Okay. All right, a standard deck of 52 cards. There's the contents. So find the probability of drawing a red card. So if the diamonds and the hearts are the red ones, the other 2 rows are the black ones. Okay. So we're going to find the probability of drawing a red card, replacing it, we're putting it back, and then drawing an ace. Okay, so I'll first just find the probability of pulling a red card. That's going to be half the deck, right? It's going to be 26 out of the 52 cards if you count them up, but I can see it's going to be half the deck if you reduce it. Half the cards are blue or red, half are black. Okay, and then the probability of pulling an ace, we haven't removed a card because we put it back, right? So then I just got to figure out how many aces. Well, there's 4 aces in the deck out of the 52 cards. Okay, 4 over 52 is going to reduce to 1/13, so I'm just going to reduce before I multiply. And then I'll get 1/26 as my probability. Okay. All right, this last one's a little different because we're drawing 1 card. We're not drawing 2 cards in a row, or 3 pieces of fruit in a row, or whatever. We're just there's just 1 event happening, but we're looking for 2 different outcomes. We're looking, is this 1 card going to be a red card or an ace card? Okay, so since we've got the deck in front, you could just count the cards that are either red or ace. That would work out. But the thing is, you don't want to double count the red aces. Okay, so I'm going to take the probability of pulling a red card, and I'm going to be adding that because there's going to be more favorable cards besides the reds. There's going to be the aces to the probability of pulling an ace. But then you got to take into account that there are cards that are both red and aces. So these two cards here fall into both those categories, right? Here's my red cards. There's my aces, and then there's the overlap group. So if I just add up all the reds and all the aces, I've double counted those two cards that are in both groups. So I want to subtract out the cards that are in both groups so that I don't double count them, okay? So the reds, and I know this is half the deck that are reds, but I'm going to leave it as 26 out of 52, just because when I'm going to be adding and subtracting, then I'll have a common denominator, okay? And then for my aces, I'll have 4 out of the 52 cards. But again, if you just add those up, then you've double counted the red aces, the ace of hearts and the ace of diamonds. So I want to think how many cards are in both categories. Well, those two, the ace of hearts and diamonds. So I'm going to subtract that out, okay? And then when we add all this up, let's see, I've got 30 minus 2 would be 28 out of 52. Okay, and we can go ahead and reduce that as well. That's going to reduce to 7/13. So 4 goes into both 28 and 52. So 7/13. Okay, that's the end of the warm-up. See you next time.